To get the bouncing box to occur on the screen, the first thing we need to do is to clear our background. Now, previously we used the background statement. Today we're going to do something a little bit different for visual effect, and I will put in a line of fill. I'll just declare I'm filling the background with white, but I'm going to also declare a transparency to that fill. So I'm not filling it with opaque white. If I declare one value and a second value, that doesn't mean I did red and green. Instead, I've said grayscale, black, white, or gray, and what transparency level I wanted, in this case 100. 255 is opaque, 0 would be transparent. So we're on kind of about a 40% transparency or so. I'd have to do actual math, and not in the mood right now. And then I'm going to just put in a rect, and I'll start out drawing from the corners and create it at the width and height of the screen. So what this does is this now draws a white transparent box over my stage. So instead of completely clearing it, I'm mostly clearing it each frame, and we'll see that it gives us kind of a cool visual effect. Now, the next thing I'm going to do is just modify my x by speed x, my y by speed y, and then I will draw my box on screen. We'll just use a red rectangle. You can use whatever color makes you happy. And then I'll draw my box at its x, y, width, and height. So currently, when it comes up, the box is going to move on screen. I might as well run it now just to see what's happening. And when I run it, we'll see that we get a box, but it doesn't bounce when it hits the margins of the screen yet. It just kind of continues. But you may have noticed that it now had a little ghostly trail occurring behind it, which is kind of fun. The next step is to go through and check for our collisions with the boundaries. So if I say if my x is less than 0, and I'm going to introduce something we didn't do before, which is a compound conditional. So when we're using if statements, we can say if something is true, but we can also say if something is true or if something else is true. But we can sometimes also say if something is true and something else is true and something else. So conditionals can be single, just if a condition is true or false. But conditionals can also be multiple things have to be true using and. But we can have a compound conditional where we are saying, well, if one or the other is true, then do what is in the curly braces. So the word or is represented in programming by using the double pipe symbol. And let me just finish typing it so we have something to look at here. Now, I can say if my x is less than 0, or if my x is greater than the width minus the width of the object, then I want to reverse direction on the x-axis. So our speed x is times equal minus 1. We can do the same thing for y. So if y is less than 0, or double pipe, and the pipe is above the return key, you'll see the straight line up and down on the keyboard, or y is greater than our height minus the height of the object, then speed y times equals minus 1. So the double pipe says if one of these or the other is true, then do what's inside the curly braces. If we wanted it to be and, the way that we represent that is with a double ampersand. Now, if I did this, it could never be true. The box could never have a y less than 0 and at the same time have its y greater than the height. So I've now created something that my y could never, ever achieve because I've created an impossibility. But we'll use the pipes for or. So we have or and as our options. Now that's just a little bit cleaner than writing, so if y is less than 0, curly brace speed y times equals -1. Else if y is greater than the height, curly brace speed y. Anytime we do something twice in our code, where we execute the same line of code more than one time, we probably should be looking to a more efficient way of doing it. And that's something that we will explore as we work on our projects over the semesters. We'll write something and it works. And we'll look at it and go, okay, that's great, but I bet you could do it better. And then we look at how can we write it with shorter, cleaner, more efficient code. So now if I run this, we'll see how the box is bouncing around on screen, leaving its nice little trail behind. Now, if I want to lessen that or lengthen the trail, we can see just by making it more transparent, we get that cooler trailing effect occurring. If I turn off the stroke on the box, so inside of setup, we just say no stroke and run it, then we get what is almost kind of a cooler looking visual effect. One of the reasons that we want to use functions in our code, what we've done in here, it's perfectly acceptable, it works, and it's fine. But when our program starts to grow beyond 30 lines and we start looking at 100, 200, 1,000 lines of code, we need to have a way to organize things in a way that makes sense. So our draw function, we've already been using functions, set up and draw are functions, and we've been using those. But instead, what we're going to do is create some new functions that allow us to take code out of our draw, and when we look at draw, we will be able to say each frame, 60 times per second, we know exactly what is happening and in what order. It's going to allow us to organize our code so that it makes more sense. So the first thing I'm going to do is construct some new functions as part of it. And these functions, I'm not going to put anything in them just yet, but I'm going to stub them out so that they're a shell waiting to be populated. Now, looking back at our original functions, we see they start with the return type, void, meaning the function doesn't give us anything back when it's done. Often if we have, say, a math function or a collision detection function and things like that, they're returning back a value of either a number or true false, saying yes, something collided, or no, they aren't colliding yet. So we use functions for things like that. But right now, we'll just start out with void. And the first function I want to make is my clear background. And my clear background is not going to take any values in, it just is going to do something. The next function I'm going to make is I want to make a function for updating the position of my object. So I'm going to update the position of the object. Now I want to make a function that checks the boundaries. So it's now going to be checking to see, have I run into the walls yet? And finally, I'm going to make a function that is going to display this box on screen. So I've created 4 functions. And what I'm going to challenge you to do is to think about now, with the code that's in my draw, what should go in each one of those functions. Because all of this code is going to need to be put into these different functions. Look at these functions, a few words about the naming conventions here. Usually a function will start out with lowercase letters, I've strung together multiple words. I'm using camel casing to do that. So I have multiple words strung together. And after the first word, each word will then start with a capital letter. As I do that, it allows this cluster of letters to become readable. And it's a convention. Now I could also use an underscore to string together multiple words, but convention when we are writing out methods or functions is that we usually do use camel case. That is the normal way that we will see things in most programming languages. So as I figure out what needs to go where, I'm just going to copy some code, put it in. Now, if I do this, so I've done that to now, if I run my program, we'll see that, oh wait, it's not working because I've created this function, but I haven't called it yet. So to call a function, I'm just going to call it. So I've taken these two lines of code, and it could be in a more complex program that clearing the background is going to be more than just simply dumping a flood of color on top, but I may have a more involved process that I need to work on. And now I can see that it runs exactly as it did prior. Now if I go back, let's see, update position. Updating position for the object. Position is X and Y. So I have these two lines here, X and Y. I'm modifying them by the speed property. So I'll copy those, comment them out, paste that in. Okay. Now I can go back into my program and type in update position inside the draw function. So when I call a function, I put the function name, and then I follow that by a couple parentheses. If I run this, we'll see that it's updating. So far, so good. So I've cleared the background, I've updated the position. I have two more that I want to populate. Check boundaries. I'm going to grab the boundary check code there, copy that, comment out the original, paste it into check boundaries, and then display box. We need to grab that, put that inside of our display. So if I run right now, we get nothing because I ripped out my boundaries and my display, so nothing is showing up. But I can go put that in, display box, and check boundaries. Now if I run this, we can see there is no change, and it works. Now I can clean up what's in my draw function here. If I delete everything else, I'll suddenly see the real value. So anytime you're moving code from one part of a program to another part, I recommend that you don't cut it, you don't copy it and then delete, you just comment it out, put it in where it's supposed to go, and then once you know it's working, then you go back and clean things up. Because now that I've done that, we can see that our draw function is much cleaner to look at. My draw function also has a much, instead of just seeing a bunch of lines of code and having to mentally go, okay, what does each one of these do? I can say, okay, the first thing I'm going to do inside of draw is clear the background. Then I'm going to update my position. And then we can display the box and check boundaries. Now I want my check boundaries probably not to be there, because if I think about it, checking boundaries really is kind of part of updating the position of the object. So it almost makes, not almost, it does make sense that when I'm updating my object, then I should check boundaries there. Right here. Because it really just makes sense that as I clear the background, I update the position of my box, I draw it on screen. But checking boundaries is really, it's part of updating the position, because I'm finding out, hey, have I hit the edge? If so, let's go do something else. So it makes more sense to have check boundaries occurring inside my update position code. So now looking at it, draw is even more legible. I clear the background, I update the properties of the box, and then I display it on screen. Then I can go through and look at what are each one of those pieces of my program doing. Now for kicks, when we look at this, now draw really doesn't care. Am I drawing a box or am I drawing a circle? It doesn't care. So I could just as easily now go into my display, and if it was not just a single box, maybe I have more items in here that I'm drawing. So maybe I have another box. So I want them to kind of be overlapping a little bit. So now I have a boxy, kind of Mickey Mousey sort of thing. But now if I decide that, well, let's see, I want the background to be a little bit more opaque, less trails, just change that, and now we can see how the value changes. So working with this, we'll see that by organizing the code into logical pieces, so each function is really doing one thing. Checking boundaries is only checking boundaries. Updating position is updating position, of which it includes we need to know, have we hit the boundaries? Because that is, the boundary is part of a position. Displaying the box is just displaying it, but we've separated out updating the position of the object from how we want to render or display it on screen. And by being organized and thoughtful on our code, we're going to find it much easier as your programs become more complex. So I've modified the functions project so that it's now functions bad, because we have the first set of values, then the second set, then the third set. We can see that they're all about the same, but now it starts to get highly duplicative. Now if I look at my function calls, very duplicative, that's ugly. And if I look at the functions, update position, update position, update position, wait, they're all kind of the same thing. They're doing the same thing, just with their own unique set of values. And it's this way of working where we have an object template, and now we have multiple instances of that object on screen, hard coding it into our program. Okay, so I just have this for 3 objects. And that's fine, but if I have 100 objects or 1,000 objects, life would really, really, really suck. And this would be a horrible way to do it. So that's why this is now the bad way of doing it. And what we're going to look at next is how we can create an object template. And when we do that, we can put as many copies of that object as we want on screen quite easily.